Hello, my name is Briar Flansburgh and my project is on the large intestine and its role in nutrition. How the physiology of the large intestine relates to nutrition. What is the large intestine? The large intestine consists of the cecum and the colon. It begins at the right iliac region of the pelvis, just below the right waist, where it continues from the small intestine and goes up the abdomen. Thereafter, it goes across the width of the abdominal cavity, then it turns down, continuing to its endpoint at the anus. The major functions of the large intestine are the reabsorption of water and compaction of feces, the absorption of vitamins liberated by bacterial action, and the storage of fecal matter prior to defecation. The large intestine is made up of the colon and the rectum. The colon is a tubular structure about 1.5 meters in length. The colon is continuous from the small intestine, from the ileocecal valve. The parts of the colon include the ascending, transverse, and descending colon. Over the surface of the large intestine are longitudinal muscle fibers called tennae coli that are about 5 millimeters wide. There are 3 bands, and they start at the base of the appendix and extend from the cecum to the rectum. There are saculations, little bags or sacs, called haustra that are characteristic of the large intestine that helps distinguish it from the small intestine. The microscopic structure of the large intestine. The large intestine is lined internally by a layer of mucosa. This mucosa contains tiny indentations called the crypts of Lieberkühn. These contain various glands and goblet cells that help in secretion and absorption of fluids. There is also a large amount of lymphoid tissue that helps in maintaining an immune barrier. Macrophages lie at the subepithelial layer. Some more functions of the large intestine include absorbing water. It takes 24 to 30 hours to complete the digestive process. Further digestion or breaking down of nutrients does not take place here, but it helps by absorbing water and making the stool solid. The large intestine also helps in absorption of vitamins that normally live in the large intestine. These are friendly bacteria called commensal bacteria. There are over 700 species of bacteria that perform a variety of functions. These commensal bacteria break down the undigested polysaccharides or fibers in diet into short-chain fatty acids. These can be absorbed by the large intestine by passive diffusion. These bacteria also produce large amounts of vitamins. The most important of these is vitamin K and biotin. When the vitamin intake in diet is low, this can be an important source of these vitamins. Vitamin K is needed to modify certain proteins required for blood coagulation. A derivative of vitamin K is capable of blocking the blood-thinning actions of anticoagulants like warfarin. It also reverses the tendency of these drugs to cause arterial calcification in the long term. Biotin plays a key role in the body. It supports the health of the skin, nerves, digestive tract, metabolism, and cells. Biotin may also help treat some types of nerve pathology, such as peripheral neuropathy that can result from kidney failure or diabetes. Reducing acidity and protecting from infections. The mucosa of the large intestine also secretes bicarbonates to neutralize the increased acidity resulting from the formation of these fatty acids and other digestive components at earlier parts of the intestines. The mucosal layer of the large intestine also acts as a barrier, protects from microbial infections and invasions. The large intestine, particularly the appendix, is the confluence or juncture of several lymphoid tissues. These play an important role in immunity. The lymphoid tissues of the large intestine also help in the production of antibodies and cross-reactive antibodies. These antibodies are produced by the immune system against normal commensal bacteria, but also may be active against related harmful bacteria, and this prevents infections. Damage to the colon. Constipation can lead to abscesses in the colon, also known as diverticulitis. When diverticula rupture in the peritoneum, peritonitis, bowel obstruction, sepsis, colonic fibrosis are possible complications. And diverticulosis can be diagnosed by x-rays or CT scans. Alright, so here is a picture of acute peritonitis, and then a CT scan, and it points to the diverticula. And here's an x-ray of diverticulitis, and also a cross-section of diverticulitis. Hello, my name is Briar Flansburgh, and I approve this message. Hey y'all, it's Paula Dean. Today, I'm going to be teaching you about the large intestine.